what this we're going to start is get as far as creating a virtual machine. That takes a bit of time, so then we're going to jump out of this. I'm going to confuse you, and then we'll discuss CSP4 Live. So we're going to be moving around a bit. Is everyone at the create session?
Yeah, I think both of them. I see bubbles blocking. Maybe it just needs to please.
Okay.
The next one. Great. Now we can do it again. And then you have your
So if most people have done that, in the interest of time, I'm going to start on CCP4. So, if you have CCP4 installed locally, it's best to use that, it'll be quicker. If you want to play with the Detris Cloud later on, play with the Detris Cloud later on. But now I'll switch across and do a bit on CCP4, then we'll come back and see how this is doing. But it takes time. So I'm going to briefly say something about CCP4, but then I see a lot of you have live instances launched anyway. And then I'm going to show you how to register for CCP4 Cloud Remote. Then just take you through a little bit about CCP4 Cloud. So this should have been given by my boss, Eugene, but unfortunately he couldn't be here today, so I'm afraid you have me instead. Now, CCP4 have been going for a long time. We were founded in about 1978, 1979 to support work at the Daresbury synchrotron. That was the world's first synchrotron that was built from the ground up to support research not associated with just accelerating electrons. So it was a big thing. In the old days, your data collection would take a long time. You could go to the pub, you could have a couple of beers, you could watch the monitor and see that the beam had dumped. You could have another couple of beers. But the old days, now, thanks to our friends at Detris, where it takes seconds to do a data collection. In the old days, you used film or more laterally as CCP, and it took a long time. Things have changed. We've been funded by various UK research councils, and although we are free to academics, we charge commercials license fee, and that pays for people like myself to work on the suite. Now, it's a fairly large collaboration, mainly centred on the UK. We have collaborators, well, we ourselves are situated near Diamond, so you can see CCP4 on there. If you wondered where Daresbury was near Liverpool, which is shown on the map. We work closely with York University on CCP4I2, tools like Privateer, etc. Liverpool do a lot of work on bioinformatics. Newcastle do work on ligands, and Cambridge, Randy Reed's group, obviously do phaser, and there's also other groups in Cambridge. At the MRC, Gary Mercer does a group for RefMac, Paul Emsley doing COOT, Mohan, etc. And we work with other groups throughout Europe, so Dials, who are at Diamond or in the States. We have Leiden, the group in Leiden do experimental phasing. We work with Isabel Wisson, who now looks after SHIAX, but also develops molecular replacement tools like Algae, etc. So it is quite a big collaboration, and it is a collaboration, so you'll find that CCP4 will not necessarily just have one way of doing things, we'll have multiple ways, because we're friends, but people are not instructed what to do, just work collaboratively together. We have license. The licenses are all over the world. That's commercial licenses, maybe not commercial licenses, let's see commercial. Licenses throughout the world, and we run workshops throughout the world as well. So workshops, US, South America, Asia, etc. So one of the aims we were set up with is to teach protein crystallography. And as part of that, we run these workshops. We also have other tools. So there's the CCP4 Study Weekend, which occurs every year in January. Not necessarily on a weekend. I don't think it's been on a weekend for the last 20, 30 years. And what it normally does is cover protein crystallography or structural biology from a slightly computational end. This year it's on ligands, fitting ligands into protein structures. Now, it happens, this year it's in Nottingham, in the UK. I know it's a long way away, but it is also streamed online, so you can register and attend the lectures online. Obviously, you miss out on the social element, but it's aimed to be educational, so have introductory talks as well as main talks. The talks are also recorded and are put on our YouTube channel if you want to watch them back later. Also out of this comes an activities special issue. And if you go back, there are many, many activities special issues. And indeed, if you're interested in things like data processing and want to know the theory that's gone into programs like XDS and DIARS, there's some very early ones from about 1980 that have Wolfgang Couch's original descriptions of XDS, etc. There's a lot of useful information there. It's all open access, so you can read them anytime you want. Okay, structure determination. It looks actually like this would be too basic, but you know how it goes. We do the experiment. Hopefully we do the experiment well. We illuminate our crystal. We correct diffraction spots on a nice detector from the Detris, another company, and then we'll spend the rest of our time trying to reconstruct the contents of the crystal. Now, as you remember, we don't have phases when we do experiments. We'll collect the intensities, we want the amplitudes, and we want to somehow get the phases and bootstrap our way into a solution, cycling round and round until we've got the best solution we can get. Now, the result of the experiment is not so much the atomic model, it's the map. We're just using the map as a model of, we're using the structure as a model of what's in the map. In reality, you know, we have to get those phases. The phases need to be calculated, and we provide various tools for doing that. But, you know, very much things have changed. You know, since DeepMind published AlphaFold 2, and suddenly they came up with what looked like very good structures. So at that point, life became so much easier. You didn't spend your time crafting a model, or having to do experimental phasing with a heavy atom soak or sulfur sand, etc., to get initial set phases. I would still say that collecting an anomalous signal is a good idea. It can give you additional restraints on your refinement. So if you have nucleic acids, there's enough scattering in there that you can tie down the location of the nucleic acids much more. Same with salt. If you have disulfide bridges, you can tie down those locations a lot more. It gives extra restraints to refinement. So probably always should affect as if you have an anomalous signal, and then if you don't, you don't. Okay. So, steps in refinement. We want to derive the structure factor amplitudes from the intensities. We want to approximate the initial phases by some method. Now, molecular replacement, 99% of the time. We want to convert those approximate phases into beta phases by model building, and we want to then interpret the remainder of the map to get beta phases, etc., and cycle round and round until we think the referees will not reject what we put in. We don't care about the BDB, they'll accept any old rubbish, but we want our paper published at the end. Okay, so that is the structural solution process as a sort of diagram. Initially, when we're doing the data collection, we normally have made a couple of assumptions. We have, assuming that we know the contents of the asymmetric unit, and that we know the space group, at least the Larry group, and we'll take that forwards. Now that's the structural solution process outlined, and that's the elements that are covered by CCP4. We don't collect data at the synchrotron, so that last experiment is not in our remit. If you have got a crystal covered in a fuzzy layer of amorphous water, or worse, more structured water, you've got ice rings, or if you've done the experiment and your crystal dropped out of the beam, etc., we can't help you. You've done it. Same thing if you illuminated your crystal at 100% non-attenuated beam, destroyed your crystal in the first few images, we can't do anything for you. If you have decided to collect your data at 1 degree oscillations, and you have a nice long cell edge, so your spots overlap, we can't do anything for you. So the note is, that experiment is your last experiment. The rest of it is on a computer. So please get the experiment right. You've probably spent in your time, etc., about $100,000 getting the crystal. So treat it nicely. But the rest of it, later on, CCP4 offers a wide range of tools for you to use, right the way from data processing, styles, or markup, down to the deposition stage. Okay. That's us with some software that is included in the suite. So we include CUDs, multiple interfaces, Artois, ShellX, etc. Lots of tools in there, lots of lovely tools. Now, that would be all fine and dandy. So you see we have Phaser, we have ShellX, we have RefMac, more probability, lots of things, excellent. But if you're like me, you're a bit lazy, you'd rather not run individual programs. So we also have multiple automated pipelines, so for data processing in CO2, for molecular replacement, things like slicing dice, Mr. Bump, which Ronan will go into, for model building, model craft, nuclear find, Artois, CCP4 build, automatic tools for model building, etc., etc. So we often hear the complaint when we do a workshop, we show people step by step how to do things, as if things have gone wrong. We also have automated tools for when things go right, and it can be really simple. That's what we've got. Now, if you want to know more, there's copious documentation online. So there's the CCP4 Cloud Roadmap, which just gives you more information about CCP4 tools. There's also the CCP4 Bulletin Board, which has something over 6,000 subscribers and has a wide range of experience. There's some real experts in that. You'll find people like Kai Dietrich, Eleanor Dodson, Graham Winter, Randy Reed, Aileen Mackay. They read the list, they reply to things on the list. So it's not only for my CCP4 program didn't work, help me. Actually, you should email us at CCP4 at SDFC ACUK. The BB is also for assistance with crystallographic problems, and an excellent resource. There's also, it is archived, but probably not so easy to work down. Right, the documentation, as I said, linked from the roadmap, there's plenty of documentation on how to run the programs, procedure, etc. Now, I did look around, and I did see this interface, CCP4i, from about the year 2000. So what happened since then? I think at that point it was CCD detectors, if you were lucky. You were collecting 1 degree oscillation. As I said, you were taking your time about it. Happy days. Things have changed. We are no longer supporting this interface. It's just in there because people still use it. New tools have not been added to this interface. So please, do yourself and ourselves a favor. Try one of the new interfaces. In 2016, sorry, I'll also say, look, this interface, for its time, was a nice interface. It gave you a chronological list of the jobs you'd run. It gave you a list of steps you could do, the programs you could run, and reasonably pretty output, so you could see the graphs, etc. It also had a very handy tool that it could give you the command line you needed to cut and paste into your command line script, so you didn't have to use an interface anymore, you could just run from the command line. Then, what's it, 10 years ago now, CCP4i2, a newer interface built on newer technology that was prettier, still allowed you to track what you were doing, and gave you much nicer output. So if you compare the output of a job from CCP4i to the output of a job to CCP4i2, it's night and day. It's much better. It gives hints and so on. It's a much better interface, and it has new tools in it. So that's a big improvement. However, life goes on and things move quite quickly, and now everyone, Steve Jobs went, I introduced iPhone, and then he introduced the iPad, and suddenly everyone wants to do things on the web. So CCP4 slowly but surely moves into that world, and we bring along, since 2019, CCP4 Cloud. It's a new interface, yet again. It runs in a web browser or an electronic. It can use CCP4 resources or your local machine. It has new tools in it. It has pretty output, and it has a nice way of tracking what you've done. So it's a really nice tool. It also has tutorials built in, as does CCP4 i2. So you can use the tutorials to learn how to use CCP4. So it's really good. It's a nice interface. It's developing quickly. So please don't use it. You may find that your boss uses that. Your mission will be to persuade your boss not to use that. Or particularly any interface with PH and stuff. So we're going to use that one. Why should you use it? Software is getting more complex. Oh, particularly if you do CryoEM, you'll see programs like, all the alignment programs, the model development tools, will use GPU acceleration. That's slowly making its way into protein crystallography as well. It's pumping up the compute resources you'll require quite substantially. Now, your laptops are getting more powerful and can do lots of things, but they still, I don't think you're going to be running bolts or Chai on your laptop. So, growing software demands, people are using more data, so you can collect faster. If somebody's working on ligands, they may be collecting 200, 1,000 data sets. That's not easy to do, it's not easy to track. So the idea is that a program like CCP4 Cloud will allow you to access the resources and give you the tracking and give you reasonable security as well. Now, if you're worried, you're working on the greatest ligands ever, and it might have a commercial possibilities, you can run your local CCP4 Cloud on your machine or on your own resources or in the Detris cloud. So it's not, you're not tied to using CCP4. No, you are tied to using CCP4. You're not tied to using our resources. So, okay, it covers most things, right the way from image processing to through molecular replacement, model building, refinement, validation, deposition. It does it all. Fantastic. Right, it's all in there, and a large number of tasks. Individual tasks is probably over 100 now. This slide is 4 or 5 months old. So lots of available tasks, and these are increasing. And as I said, well, things are changing quickly, so it's envisaged that certainly at Synchrotrons we work closely with, you'd be able to run your data processing and Synchrotron, obviously. So they will probably run something like AutoProc, ZIA2, or HKL, and then you can automatically upload into the CCP4 Cloud and do your structured solution. This is also the vision Detris have, that you'll be able to upload from your Beamline into the Detris Cloud and do your solution there. Now, that sort of thing is actually a reality. Certainly if you work at somewhere like Diamond, we could do that already. Now, not everyone collects data at Diamond, you collect at other synchrotrons. And let's say you want to get your data to CCP4 Cloud. We have a Globus endpoint We have tools so you can use Globus to upload either from your local machine or from the Synchrotron if they have a Globus front end. You can load your data up into CCP4 and just start working from there. So you can see it, you can data process it again, etc. Now, our last check gave those as synchrotrons with Globus endpoints. We're kind of lacking on the far left of the map. There doesn't seem to be any in Asia, so we have to talk to Big Mind Scientist or to the synchrotrons to try and get this set up. But anyway, there will be Globus or another sort of endpoint available for you to upload data. Okay, getting into the cloud, well, you can push using Globus, you can fetch from the cloud using your Globus ID, etc. So lots of ways of getting your data in there and then running CC4 Cloud and getting your structured solution. Right. If you're running CCP4, you've got it installed, there are several ways you can run CCP4 Cloud. So the CCP4 Cloud Local, which runs local on your machine, and what you can run in the Detris Cloud, and the CCP4 Remote. CCP4 Remote will connect to a remote cloud and use that. Now, by default, that's our compute, but if you have a local instance of CCP4 Cloud, as in on your own compute center, you can point towards using that and you can do calculations on that. You can also access CCP4 Cloud through a browser, but then you don't get all the tools. So, okay, that's a configurator. As I said, you can change which version of CCP4 Cloud you point towards. Now, if you just work through the browser, you will not have the local daemon running, so you will not be able to use COOT, you will not be able to use DUI, you will not be able to use CCP4MG, you will not be able to run CO2, so you will not be able to connect that CO2 locally. You will not be able to connect the resources on your local machine. So it suggests that if you are running CCP4 and you have CCP4 installed, and you want to use our cloud instance, you run using CCP4 Remote. Okay, it's available in lots of ways. Now, I did see quite a few people already having CCP4 Cloud open. So that's fantastic. But I'm going to break off and try do a demonstration. So, finding Zoom present window. I want to eventually, yes. So CC4 Cloud, if you go to, I just did what I told you not to do, didn't I? Because I am a silly person who's very lazy. Right. Don't do what I did. That's totally wrong. What I want you to do is load CCP4 Cloud Remote. I can see Rod and Chicken's head at the back, which will then launch CCP4 Cloud in my browser and the local daemon. Now, if you've got a standard installation, there should be icons to launch.
Maybe ask everyone if they have
Yeah. Yeah. So people manage to click or type CCP4 Cloud Remote to launch CCP4 Cloud Remote.
They might not all have CCP4 installed.
If you don't have CCP4 installed, later you can try using Detris Cloud. Now you can just go to the browser window and do the cloud.ccp4.ac.uk to open up this lovely minimalist page. Now, if you haven't used the cloud before, then you will have to register to use it. So there is a button, can I do, not blind to me. button up here. So if I click on register, hit the registration page. Which allows me to set up a user. If you've done this before, don't need to do it again. Although it's wonderful for our statistics, if you do it multiple times, then we tell our parent organisation we have multiple users. Keeps them happy at least. So I'm going to register. Using email address, and let's say that I'm an
Can you
academic.
increase your font a bit, Chairman?
Hmm?
Increase the size of your font.
Okay. Right. So I chose a name, and I put in an email address to which a password will be sent, initial password will be sent. And I choose my license type, academic. And have a look at the feedback agreement. So how much information I want to give those pesky CCP4 developers. Do I want them to look at my data if something's gone wrong? Do I want them to not look at my data at all? So 3 levels. I'm not even sure, so you can read them. Your data may be, so the first one, your data may be used if there's a problem. If you crash the cloud, you crash your program, we may look at your data, try and figure out what's going on. Agreement 2, if you're doing your processing and maybe we fire your job through our development cloud, it does better on the development cloud than it does on the cloud, public cloud. You may get us contacting you to give you information on how to process further. Or you may decline, basically don't contact us. So I'm just going to choose one. Okay, and then I'm going to hit the button to register and send an email. Login. No, I've used that login name before. Login name must be provided. Okay, yes. Okay. Right, it gives me the message telling me what to do next. So to check my email to see if what the temporary password is. And then I go back to the login page. So then once I've logged in, I get the instruction to change my password from the random password that it gave me. So I'm going to give it, if you know an English keyboard, this is the second most common password in the English speaking world. Surprising enough, the most common password is 1, 2, 3, 4, 5, 6. Okay, and I save my changes. I have to log in again. So after resetting my password to something I can remember rather than a random list of 6 characters, I finally make my way into CCP4 Cloud and faced with this. So a list of all my projects. Obviously I don't have any at the moment, but it does give me a way to, I can organize projects that are related together. So if I have 2 projects that are similar, I can connect them together. So that's an organizational tool. I also have the ability, well, various tools. So if somebody shared a project with me, there's the join. I can join the project. I can import a project, so a pre-existing project that it's so small. So I can upload a pre-existing project to Cloud, although this may take a long time, so well, it may take a horrendously long time, even longer than that. I'm not allowed to close the dialogue, so maybe that was a mistake. Right, I can upload a project. If I have an existing project, I can archive I can download the project onto my local machine with export. That, the format of that is a standard zip. So you can unzip that and check what's in there if you want. So it is a very, I'm going to cancel that.
Can you just start from the beginning again? Just start the project again?
Yeah, I'm going to just display around. So across we have help information, which just gives you information on CCP4 Cloud. So we have the CCP4 Cloud documentation and the documentation. Up here, on this side, I can get back to that accounts page. I can change additional information. I can get the Cloud Run ID, which allows me to launch a remote job using my local CCP4 Cloud or CCP4i2 or CCP4i version. So I can start a job locally and launch it on CCP4 Cloud. If I set my I can set my Globus ID to upload Globus, Globus endpoint, etc. So I have all the tools for managing my account there. There's a series of tutorials on there, which you can, so under tutorials, we have various tutorials in there. It can take you through using CCP4 Cloud. So if I just go to something like experimental phasing, I double click on that, it will import the tutorial into my project. You can see I've got instructions and data I can play with. So I can use those to just train myself. And many of these you'll find have the tutorial instructions on there. So there's a step-by-step process of, in this case, running Crank 2 to do experimental phasing. So there are, if I go back to my projects, click on that again, you'll see there are a large number of tutorials covering just about all the structural solution process. We also, if I click on data from images, there are various data sets included in there. And later on, we'll be just trying this in the N2 flow. So we have data sets processing. So if you want to try data processing with CCP4, just experimenting and teach yourself. We have some data in there for you to use. We also have demo projects, and sometimes people teach using CCP4 Cloud, so we can upload information for university courses into there, so people can study using that. So it's a good education. Right, that's tutorials. By standard, you would add a project, you get the instruction on, no, giving the basic information. So it's a project ID and a simple name. So obviously you're going to give it something sensible so that you can come back 6 months, a year from now, or your supervisor can come back 3 years from now and have a clue about what's going on. So I'm going to call it Fred, in typical programmer style, so no one will have a clue what's going on. Okay, add a project Fred. I drop into Fred, and you'll see I then have various tasks made available to me that I can operate. So the task list, the all task list is in reasonable order. So running from at the top data import through structure prediction, data processing, molecular replacement, so phasing, density modification, model building, refinement, running code, adding ligands, analysis, and various toolboxes. So the task list runs in pretty well the order you'll do the structural solution. Now, you'll see numbers next to there. That's the number of jobs I'm allowed to run at this point. So I got a fair selection of jobs available. So obviously for the import, I have a lot of jobs available, but some of them have a do not enter sign. So the circle with a red circle, white line. Now, it can be a bit annoying going, why can't I run this job? So I'll actually scroll down to the replacement. So automatic replacement. So at the start, I can't really do very much. There's not very much information in there. And I can't run my AutoMR with Mr. Bun. Why can't I? I can click on it and it basically says, I don't have the information required to run the job. So I have to then upload what's required, the protein information, any models, reflection information, etc. So if you can't run what you think you should be able to run, have a click on the job anyway and just see what you require. Okay, I'm going to import some data from this CCP4 Cloud, so a data import. And I'm going to import, I can import from cloud storage, which then allows me to browse information that's already on our server and upload that. So if I was to click on tutorials and some of the data, from images, NPM2, I can import information that's required, such as sequence, PDB, the README, an unmerged MTZ file, etc. If I select those, import those, CCP4 Cloud will try and interpret what I'm loading. So you see, it's picked up that I've tried to load a sequence, and it's asked me, well, I have to confirm whether it's a protein or not, protein, DNA, or RNA. So I apply and upload it, and import it will ingest the information. So various bits and pieces, you'll see I've uploaded some a PDF file, and I can display that if I wanted using Upload. Just check it was roughly what I wanted. I can also have a look at that MTZ file. Now, Cloud will run a sanity test on it, on the MTZ file. Now, MTZ files come in several different forms. What you should note is the major ones are merged, where we've taken all the symmetry-related reflections and averaged them and estimated the errors, the signals. Now, that's what you use for most of structural solution. It is not very flexible. There's also unmerged data, which records each observation independently. That is very flexible, but currently not used downstream, although people like Kitaro are looking at that. Now, there are two forms of unmerged file. There are scaled ones that have been through something like Xscale, Dial Scale, or Aimless, where we have put the related reflections on a common footing. So we've corrected the observations for absorption, possible radiation damage, etc. So if we know two reflections are related by symmetry, we'll assume they should be the same. So we can use that information for estimating a sigma and a mean. That's all fine, but you just have to note whether your file is, unmerged file is scaled or unscaled, because if you then run it back through Aimless and you rescale, it may have knock-on effects on the sigma estimation. It's just something to note. But I have loaded an unmerged file, and it gives me some information about, it's pointless. So it will look at the contents of the file and just run a sanity check. The sanity check for an unmerged file, it will run pointless, and that will just check various things, possibility of twinning and various symmetry operators, and just have a look. I'll talk about this more later. We'll see. It gives various information. I can also, if I'm running remote mode, have a further investigation of what's in the MTZ file. So I can look at the summary of what's in the MTZ. Ooh, normal character breakdown. The HK, list of the HKLs, etc. So you can tell this is an unmerged file because it has the reflection indices and which observation it is, which image it fell under, etc. And then the fraction on the image, where it fell on the detector, the rotation angle, etc. There's a lot of information in there. And we can also see various, how we're doing for the data collection, various zones. So that's a tool called View HKL. You can just sanity check, or you can just check your MTZ files with that. Right. Now, typically, if you're collected as a synchrotron, it's punched out an MTZ, merged MTZ file, and you'll be just running CCP4, etc. by uploading that. So I can just add a job. I'm going to do another data import, and I'm going to run that locally. Oh, this is where I wish my eyesight was better, because this text is really small. And I'm just going to load an merged MTZ file. And this would be typically what if you load up after your collection. And eventually, it will upload. Okay, finish the import. It again run the sanity check, but this time it will run sanity check for merged files, which is basically Citroncade, and you can look at things like Wilson plots. There's a summary of the information you've got. Wilson plots, L-test analysis, whether it's twins, acentric moments, again. A sanity check that I've uploaded something ridiculous, and that I haven't uploaded data to way too high a resolution. Now, once I've uploaded the information, I can add a job. Now, you know, I could either add a single task, step through, or I can automate it. And I could automatically run a workflow being a series of tasks joined together. So we have various of these, largely based on around molecular replacement. So if you know it's been solved before, there's a good homology in PDB, you can run Mr. Bump or Mortar, and that can do all your data processing. We can also run AlphaFold if you use a remote C64 cloud. So if I were to click on that, I could give it that information, I could click go, it will then do an AlphaFold calculation, a molecular replacement, a model building, a refinement. If the refinements worked, it would then drop through to doing the deposition. The validation scores, it would do it all for you. So that's the simple way of doing things once I've uploaded the information. There's yet a simpler way that if I go add a project and I click on, I don't use manual mode, I use one of the pop-ons, I can get the same workflows, but not even bother to click through various stages. So if I do this, if I click on that, and that's using structured solution, it's telling me I need a reflection data file, I need a sequence, and perhaps a ligand. Okay, so if I just add a project with that, okay. Project, and it will ask me to upload the information. I'm just going to browse down and add the same empty zip file, which I have local to my machine somewhere. I'm going to add that and add a sequence file. Now you could do this using, so I've used this from my local machine. You could do this, for instance, as this is a tutorial example, you could do this using cloud data. And if I click run, to upload the data, and it'll start, and it'll tick through running the structural solution process. Now, I go back to projects and I do this again. Don't want manual mode. I want using structured databases. Using cloud data. So if I run it again, same mode as I did, but using cloud data and the project. And if I use cloud storage, you can do this, by the way. And I browse, and I go to tutorials, data, from images, which I'm not doing from images, in M2, and no, on laptop is not there. No, I made a mistake. There's not a merged entity file.
You have to go to MDM2 with M4.
Yeah. So if I load the files and the sequence, apply, I'm not going to bother with the ligand. I can just hopefully run those. And just like CC4 cloud, upload the data and run it. So those are in the cloud tutorials. So you have access to that, so you can do that. Now, I don't know how far this will get, because I've tried, but you'll see it slowly build a tree of jobs. So we're running this, because this was a unmerged file. It will then run connected. The asymmetric units. It's running Sinbad. It's running Sinbad just to check that I haven't uploaded a known contaminant. So it happens, unfortunately. You spend your time in the lab growing crystals, and then you take it to a synchrotron and, well, maybe you get salt crystals. That's not good. Or maybe you get a known protein from E. coli or something else. It's nice if you know that early Sinbad is a tool that will check out for known contaminants and give you the bad news. But at least it gives you the bad news early rather than you having spent months trying to solve a structure, right? That's running. That's what CC4 Cloud looks like when it's running. It will take time. Okay. What I can do is you can add jobs at any point. So I can add another job to a pre-existing tree. I can branch off at any point. I could, if I thought this was, if it was running through, done a molecular replacement, and hadn't gone so well, I could rerun the molecular replacement. I could, instead of searching for all the molecules in one go, I could try and place one, then place another. I can change the refinement parameters, so I can add jobs at any point in the tree. I can add remarks at any point in the tree. Again, it's useful. When I come back to do this in a month's time, I may be looking at this and going, why did I do that? Okay, it aids memory. So I can put in notes as to why I've done things. I can delete jobs, probably not a good idea when it's running. There's a nifty tool, so you'll see we have a tree structure. Now often you get multiple branches. So you've gone down one branch and you place some molecules. You've gone down another branch, you place some molecules. You want information from both branches. You can do that. There's a handy little button here that changes the mode of CC4 Cloud, and and therefore I could join information. Sorry, I'm using a mouse pad, so I can then highlight multiple steps and join the information together and proceed down. Right. That's running. I've gone way over time. Did everyone manage to launch just a quick job in C64 Cloud? Everyone's looking forward to coffee. Everyone's wondering what they're doing. Right. That's a brief. That's an overview of C64 Cloud. If you're running it in anger, most of the time, a lot of the time, you'll be able to just use those workflows. So when you script a project, you just do sort of manual mode, choose one of the workflows. Often people just choose AlphaFold, give it a sequence, and an empties out file, go, let it run, see what happens. Then if that doesn't work, such as, let's say your AlphaFold model has a large conformational change, well, then you'll have to branch off that, and that man's going to show you how to do that. Now, I'm going to cover a bit of molecular replacement, not molecular replacement, a bit of data processing in C64 Cloud. You'll be glad to hear it's limited, so you won't rabbit on for too long. Are there any questions? There are no questions at all. Right. So if you launched a job, you can just let it run. We're going to run a tutorial, so I have to think, because I've suddenly switched it from home. Right, so I'm at the beginning. You're glad to hear we covered some of this already. How to go with it. So, there's the roadmap. Data processing or image processing in C64 Cloud. It's limited. Really, if you're online, it's ZIA 2. If you launched in remote mode from your laptop or your desktop, you've got access to others. You can run locally processed ZIA2, GUI, etc. So you can have more control. I'm going to basically look at ZIA2, Aimless, and a bit of the DAO's GUI. This will come through as two examples. So there's going to be MDM2. You've already seen MDM2. That is what I launched the automatic solution on. We're going to look at MDM2 in the cloud. There's images in there, so we can process those. I can then pass that across to Ronan. You can then do molecular replacement on it. But here we go. There is documentation. If you're at that stage and you have a job open, you click the bottom left L, it'll give you more information. There is tons of tutorial data, and a lot of it has images in there. So if you looked at the 4 images, there's various data sets. There's Jerry, there's might be one tel, there's the thermotine, there's MDM2. So you can try, most of these are fairly small. It would be lovely to let you loose on 360 degrees, 0.1, but it'll take a long time. Okay. The tutorial data, as I've shown, you click on tutorials, you can then navigate down to the various data sets. If there's one thing I want you to take away from data processing in CCP4 Cloud, you can't necessarily do it in CCP4 Cloud at the moment. You will be. Please, for heaven's sake, look at your images. Human eyeballs are very good at picking up patterns. They're very good at picking up problems. Computer programs are not necessarily that good yet. So you go to your synchrotron, you collect data, it will probably give you a spot count from the images. It'll tell you you have so many spots, so many strong spots. Fantastic. Ice rings give you a lot of strong spots. So you might be sitting there thinking, I have a wonderful crystal. Actually, you managed to collect a lot of ice information. So look at it. You should be checking. As I said, crystals cost a lot of money. You should be optimizing your data collection parameters. You should not be over-rotating, oscillating. You should try and make sure there's not fuzzy ball of ice. You should put on the right cryoprotectant. You should watch an Elspeth Gallman lecture on this, just to have an idea of what's going on. You should also check. So I checked on, proteindiffraction.org. I pulled down some images. These are all structural genomics images. And what you'll see is lots of ice rings. So nice little ice rings there. Wonderful if you want to find the beam center. And you don't want to know where the beam center is. Not great if you want to solve the structure. You also find patterns like that, loop scatter. So you see a couple of balloons. You may want to take into account there. There's a lot of background there to take into account. You also may have background in there. I don't know what caused this. Maybe there's a lot of water in the atmosphere. Maybe it's a long air path. Maybe you've got a fuzzy ball of ice around your crystal. Background's bad because it gives us large uncertainties. Detectors have spent a lot of time and money giving you a detector that counts, single photons. If you then got a fuzzy ball background, a count of 100 in the background, it's a bit of a waste of time having a nice fancy detector. You also may note some places you will have issues with the detector. Some idiot might have taken a robot arm and gouged out a bit of the detector. You may have dead pixels. You may have dead bits of panel. You may have found that your beamline hasn't bothered with a backstop and you've been aiming for the gap, and effectively you've got a dead set of pixels in there. You may need to take into account any of these. So where the detector isn't as expected, the data isn't as expected, we may have issues with automatic data processing. So please, check it. Now, Dials has a very nice tool, and I believe XDS does as well. So there's the reciprocal lattice view, so you can look at information as well as look at images. And if you're collecting on a pixel counting, you may want to slap the images together, otherwise you might not see very much. There's the reciprocal lattice view, where you can look at the spots that have been detected. That's a very useful tool. It may show you that you have multiple lattices. It may show you you have a misset beam center. There's another tool, which I think is the one XDS uses, called RS Mapper, and that takes the low resolution spots and the values from your data collection. And that's a useful tool for just looking for pathologies at low resolution. Request, always look at the data. Now, this is the reciprocal lattice viewer from Dials, and you'll see at the top, nice little curved lines. They should be straight like this. If they're like that, you may have a misset beam center. Now that may be, but maybe your data processing program can rescue you, but if it's bad enough, you will have to put in the beam center. You may have multiple lattices, so you notice we have a lot of unindexed spots, so the white spots are unindexed, and these are the white ones. You'll see these in straight lines, suggestion that there may be another lattice there. Now, I believe when Graham Winter looked at processed data from Diamond, the majority of cases did have multiple lattices. This is not necessarily a problem. As long as the spots don't overlap, it's not a problem. You can probably go with the major lattice and go on from there. However, you may check your stats and have a look to see what percentage of the spots you have indexed. And if you have indexed lots of them, just go to ask copy. Good. There's also something else you may find. If you've got nice spots, you've done your data collection, you've tried and indexing's failed, as well as miscentered, it may be you've got reverse spindle. Now, that's just the M2 example, and you see we have nice curves, and if you're larger set, you get swirls. So it's a bit like having beam center wrong, but more swirly, technically. Now, there's a helpful tool in the reciprocal lattice viewer, which will help you out. You can click on there, invert rotation axis, and see what happens. Now, if it goes from something like that to something like this, you've got reverse spindle. So you will need to tell the data processing program. Although, if the people like at XDS or Dials know the beamline is always reverse spindle, you may have a database looking it up. But not always, we're always getting surprises of new beamlines with reverse spindle. It's just something to look at. You were saying there was coffee. Right, before I run data processing tutorial, which is the next plan. Okay, there's only. Most of the time, your Synchrotron has done a good job or reasonable job of processing the data, at least good enough. They've run Autoproc, HDL, Dial, ZO2 or everything. So most of the time you're just going to upload the files like I did earlier, and from there. But I'm going to just, after a quick coffee break, I'm just going to run through a quick data processing using ZO2 and SysMicro Cloud, using the data that's in there, right? Might as well get coffee before they take it away.